Hello and welcome to my new video. Today, once again, a little problem-solving video. I want to solve a small problem with you today. I have several objects here and you can see my house right here.
You can see my garage standing. I have now specifically the outside of the garage.
Let's go. I want to show you something. We have
these ventilation holes here. I just make them sometimes.
You quickly notice, so I'll do it now.
An advertising photo, and
I'll just show you the photo in different color schemes. And here you can see very quickly with this concrete bunker, that's what I'll just call it now, the temperatures rise rapidly. That means the sun beats down on the building, and inside I quickly have temperatures of 30, 40, sometimes 50 degrees and more in the summer. To get this under control, I have worked with and experimented with building ventilators here. I've already made videos showing how I installed these openings and fans. You can find them up here under the eye. However, fans have several drawbacks. First, they require electricity and can be costly to run. And I'll show you another disadvantage.
Here, for example, a pretty powerful fan is running. I'll link how I installed this one above under the eye as well. And here you can hear the problem. They're also damn loud. It's actually a quiet fan, which is really certified to be very quiet, but you can hear it. When I speak now, it's still pretty annoying somehow. Here too, we can quickly take a thermal image. And here too, you can see the temperature is pretty high, up to 46 degrees coming out here. By the way, if you're interested in these kinds of thermal cameras, I've also tested these thermal cameras. You can also find the video under the eye, and until the 25th, or was it the 27th of July, you'll have to check. In the video, I'm giving away a thermal camera. As I mentioned, the video is under the eye. If you find it quickly, you can join here too. That's why I wondered if we could solve this differently. And here I got myself a very inexpensive option for how you can solve this. You see, I just have a 12-volt fan here. They come in all sorts of versions. I don't think my camera can display the refresh rate. The fan is running and spinning, I assure you, and it's spinning pretty fast. Here you can see the fan running. That means if the photovoltaic panel supplies little energy, the fan spins more slowly, but it still spins. If it supplies a lot of energy, the fan spins a bit faster and the fan takes about the energy it needs. Important. The system should be reasonably well matched. We shouldn't just connect any photovoltaic panel here. If it delivers, let's just say 400 or 500 watts, that could eventually lead to a cable fire in the long run. This is how we do it here. I've already explained in other videos why this can lead to a cable fire. Just make sure that everything matches up properly. The advantage is the photovoltaic panel, even if I darken it here. I'm not sure if you can see on camera, but the fan is running slower. The camera's frame rate is way off. It's still spinning quickly, even so. I've almost completely covered the photovoltaic panel. So the fan also works with very little energy from the photovoltaic panel. Of course, only when I turn it all the way around. See, we have a very well balanced fan here. It stops spinning. Now I'm slowly tilting the photovoltaic panel back up without turning it toward the sun. You see, we're still not in the sun. Now in full shade, the fan has started working again. In my opinion, that's actually a very good idea to cool or at least ventilate such rooms in the summer. Link to it is down in the video description. Let's see if it works.
So then we also have the photovoltaic panel. This little panel usually comes with something like this included. The walls can handle that. I don't want to damage my roof up here, so I'm going to attach it to my large photovoltaic panel instead. And I just bent a bracket out of stainless steel here and drilled some holes in it. And now I have the perfect bracket for the situation and can basically attach the part here. I positioned the panel facing south since the sun rises behind and sets in front. And since the fan also runs with a bit of low light, that's enough, for example. For example, is there enough light while the sun is still here to run the fan? So it actually runs continuously as long as I have daylight. So here you can see the hole where
the fan put one to install, and now I have one
fan with such
a metal plate attached.
See the fans. He has here
on the side
such ribs, and
I'll turn it over. It's a little hard. The other side doesn't have ribs. As a rule, the fan usually blows
towards the bars. Sometimes it's also written up here which direction it blows out. There are arrows on it. Unfortunately, that's not the case here. But the air comes from here and is blown outward.
You should always make sure
we blow air away from the warm object. That's what we do.
Now as well, by simply using the fan.
Attach it here. I can
do that very easily
by simply drilling it here and then blowing the air out accordingly. Unfortunately, the big advantage, we have this metal plate here. We can mount the fan on the plate whichever way we want. Accordingly, we can mount it so that here
we don't have any problems.
As you can see, the installation is going smoothly. Alternatively, you could even glue the fan on with construction adhesive. Another nice side effect. Thanks to this fan, thanks to the airflow it creates here, I also have fewer problems with mold here. I used to have major mold issues in this garage. You can find the video about it under the eye. And of course, with a fan like this, you can get that problem under control very quickly. So I've got the cable. I took it down from the roof. It's in here now. Unfortunately, with these small solar panels, they're pre-made. USB-C connectors can be seen as a pro or con. You can remove it now and connect directly to the fan. Or the fan here has a USB-A connector. And I just bought a connector adapter like this for a few cents. Or on Amazon, there are sets of 3 for 7 or 10 euros. Now you can just put the adapter on here, the USB-C connector. And you see the fan immediately starts running at full speed. It's also important to mention that we have a way here to dim the fan a bit. I'm aiming for peak power. This way, the photovoltaic panel's energy goes directly to the fan, letting it use all the available power. There's also a bypass plug here, which is a nice feature. You could just try something else.
I also have a fan here, a double fan, and we'll just connect that as well now.
As we see, a small photovoltaic panel can power these 3 fans at full power. That means I could just put it on one of my inverters here and get some extra cooling that way. So we've already reached the end of the video. If you want to recreate this little do-it-yourself project. One more tip. Make sure these plugs always stay indoors because they're definitely not waterproof. The cables can be outside, but not the plugs. Everything I used here, I'll just link for you below in the video description. That way you can easily recreate it. Give me some feedback on this idea. What do you think about it? Regarding cost, this do-it-yourself project is much cheaper than the one below. My silence fan, which I showed you at the beginning of the video, is running in my basement. That's it for my video. If you found it helpful or enjoyed it, please give it a thumbs up. Want to see more of my videos? No problem. Just subscribe to my channel. It's free. Goodbye. See you next time. Your Mark on YouTube.